Hello, everyone. I want to thank the organizers. This is a great opportunity. And my co-author is also here, Shyam Sundar. Shyam, would you just wave so that people would see you? We are very excited to be here and looking forward to receiving your feedback. So the idea is that every discipline provides a frame for showing the phenomena, capturing it, and then making sense of it. And we want to argue that the order in which we use those frames when it comes specifically to human behavior and human action, it can make a big difference. The motivation started from this observation that, let's look at this. If the lifeguard is running from the beach to the water to save someone who's drowning, or the ant is going through from the smooth surface to the rough one to reach some yummy sugar, or the photon is just passing through and going in the water to reach the salmon's eye, are we seeing the same phenomena, different phenomena? And I don't need to discuss this at length here because I'm dealing with scientists, engineers, physicists, and so you would all tell me, oh no, it's not the straight line between the 2 points, but it's actually the kinked line, and the kinked line would be the shortest to get from A to B. And many people have used this law and explained this phenomena from Euclid to Descartes to Hamilton. And in fact, also, when we give this problem to people, it can be shown that after at most 3 to 4 trials, they get it, even if nothing has been explained to them. And the ants, when we look at them, they, after about 2 weeks, find this fastest way based on the pheromone that is coming to the path from the first ant that goes back with the food to the nest. And what about the photon? Well, as Feynman said, maybe the photon is just sniffing the fastest way towards the eye of the salmon, for instance. So in the big picture, when we look at scientific inquiry, and then we want to go from animate to inanimate, or the other way, but here, because we're social scientists, by the way, both myself and my co-author, we came from engineering to economics and social sciences. When you look in terms of subject matter and the principles, for social sciences, we're looking at people or group or institutions, firms. For midway, biology and molecular chemistry, we're looking at cells, organisms, and again, groups in another form. And the inanimate existence would be captured in the frame of physics and chemistry, where the main subject matter becomes matter and energy. Now, there are certain concepts under each one of these domains, but there is a shared feature, and the shared feature is the physical existence. It doesn't matter in which domain we are inquiring scientifically and trying to understand the observed phenomena. There's always a physical existence. If you drop me from the window, if you push me and I fall down, it's the same way in the terms of observed phenomena that I fall, that if you pushed my chair out of the window. So the argument here is that social scientists tend to model from higher faculty down to the lower faculties or physical ones. So we start from immediately observable. If the ground under my feet is trembling, I'm thinking about, oh, maybe something here is not fixed and I need to fix it. But it could be an earthquake that's coming from the core of the earth. We also formalize using mechanics of inanimate when it comes to modeling, because the math is already there. So why do anything else? But there are perils in this. We overextend then. whatever we find from physical laws, for instance, when we are serving as economic consultants to policy makers and we suggest policy designs, the problem here would be, are the costs and benefits actually known? What are the dynamics that cannot be reflected in equilibrium? What are the trade-offs between efficiency and fairness, et cetera, et cetera? And Lib told me on the first day at the reception that this way of thinking about social problems have, by economists specifically, have already been captured under the title of toolism. So we want to suggest a way out of the problems or overextensions of this toolism. And that is so simple that the first time we thought about it, when we drew the problem, we didn't think that it hasn't been suggested. But in the past 2 years, when we have been presenting this idea, we have realized that this is actually not the main way that people go about this. So let's look at an example first. And I put this in specifically for Lib. He asked me the other day when we were going through this before the opening of the conference, what's the example? So the example goes like this. Let's say the phenomena of interest is altruism. How do we analyze it in social science? We say, well, there are psychological and social attributes. So we keep looking at the animate aspects of it. And then we think about reciprocity, empathy, identity, etc. And then we come to the middle and we say, well, you know, there are actually evolutionary roots that can explain why this happens. So we are now in the middle, inanimate, some hardwired in biology area. And then when we want to sit down and work on notations and establish relationships, we just use the mathematical physics. We are now in the domain of inanimate. So the extant order of modeling is, if you think about these different disciplines from the crust to the mantle, that is, we start with social sciences and whatever framework, theory, etc. it gives us. We go to biology and let's say evolutionary descriptions and ideas. If we need to have more, as I said, in altruism, and then finally we sit down with math in the core and model, and then we end up apologizing and constantly saying in almost every paper, implicitly or explicitly, and the books from the beginning, well, we know actually that this is not how people are, but this is the best way to represent it. Now, our proposal is, let's reverse this order. Let's start from math, keep ourselves intentionally there, in the realm of physics, of the inanimate, of the part that we all share in the universe of existence, and see how far we can go in terms of using specifically the laws and structures such as optimization that applies to the inanimate world in order to make sense of the observed phenomena. Like every other good work, it starts with a definition. So if you think about it, move it means put your act together. The definition of action coming directly from action in physics, principle of least action, is just a movement. Let's think about action in its simplest form, moving from A to B. A state A and state B could be specified by the actor. And here's where I want to draw the important distinction between social science modeling versus inanimate world modeling, where the actor and the modeler are two different entities. In social science, they aren't. So I invite you to think about the subject matter or a subject matter in your own discipline. If you're an economist, you can think about decision to buy something. Psychologist, you can think about bonds between people, different affects. You're a biologist, you can think about reproductive mechanisms, a philosopher, you can think about free will. And if you're a physicist, you can practically think about anything you want. And you would say, yes, action is a movement. So this is a simple, agreeable definition. What am I going to do with it? Well, first, we'll look at what this definition can give us if you are looking at it from the viewpoint of the actor himself or herself. And then, as I said, the only characteristic that I want to give to my states, A, beginning, and B, end, is whether they are specified in the eyes of the actor or not. So if they are both specified, then we are looking at observable paths and observable phenomena. And in this case, we are just falling into physics, and we are allowed, without any apology, to model everything in physics. As soon as something becomes non-specified in the eyes of the actor, so the beginning or the end, for example, if I am thinking about habits, customs, rituals, then neither the beginning nor the end is exactly specifiable in this sense. What do I do as a modeler? I collapse it to cell one. The same applies to, for instance, wishes and dreams. If the beginning is non-specified, but I have a wish that is the end is specified, what do I do when I want to model it? I collapse it here. And the same applies to this cell. So when it comes to modeling, everything collapses to cell 1, 1. Let's do an exercise of what happens when I take the direction that exists now in social sciences, that is going from higher framing to lower, versus what we are suggesting here, that is from the core outwards. Looking at all these phenomena, from marbles that are organizing themselves in jars, or fillings, iron fillings in a magnetic field, or the way that the simplest worm has organized the connections between nodes in the brain, or a darling of cognitive science, which is catching a ball that's coming from up high, the model would end up being maximization of some sort. So let's use one of the very basic, very popular and general principles in physics, that is the principle of least action. Use it as a frame which can, I want to show, capture the animate action observable, but use only inanimate attributes. That means just take principle of least action at face value, specify in the observable phenomena an action element, some given variables that remain external, and the path. So here, let's look at catching the ball, because it's very interesting, and actually evolutionary biologists like it too. So Richard Hawkins famously said, when a baseball player is catching a ball, it's as if a homunculus in his brain is calculating where the ball comes down. What do we do with it? In the current method, we are looking first at the outside. Oh, he observed and he caught and he ran towards it. So there must be something in the brain going on. And then in the proposed model, we just say, well, you know, we are sitting here, and what we are looking at is basically the ball reaches, let's say, about 1.5 meters above the ground where the player can catch the ball. But the action element here for the person who's moving from out inside, and here we are thinking modeler, would be evolutionary capacity of holding the gaze on the moving object against a busy background. For us, it simply would be there's a fixed angle of gaze, or I'm optimizing, meaning I'm making the change of the angle remain at 0. And the path would remain the same. So the only thing that changes here, actually, when I change my direction of framing in different disciplines or different layers of the framework for understanding the phenomena, in this case would be how. I can continue. We have actually an extensive table for many phenomena, from the simplest to the most complex, that would be decision paths. And we do the same exercise. What happens if we reverse the order? Why do we do this exercise? Because there will be specific methodological gains. One is that there is a huge debate ongoing in cognitive science, economics, behavioral economics, throughout social sciences, whether optimization is a proper way to model human behavior or not. And in this way, we are just blocking it out because there is no role for intention or purpose here. We are remaining in the inanimate. And the other part is that methodological individualism, criticism also goes out. We are not doing any form of direct aggregation. And therefore, we allow for emergence, for instance. That would link us to what thermodynamic people are talking about. And we don't fall into the trap of reductionism. And I think my time is up in 1 minute. So when we put physical versus social phenomena, what's important in the scientific inquiry versus the subject matter is to look at different effects. And in this case, for social phenomena, except for observation effect, everything else is different. So principal universality does not exist, whereas for physical phenomena it does. Method neutrality definitely does not exist. I remember Garvin saying yesterday that economists are very dangerous. Yes, this is why they are dangerous. And explanatory equivalence, which exists for every good mathematical structure, again, does not exist in social phenomena. The dual of a problem has a very different policy implication. So I pass this and I just summarize and sum up. Please send your comments. Here is my email. I'd love to hear everything that you have to tell us. The summary would be, the message is, yes, toolism is happening. And our suggestion is, let's reverse the order of framing. Thank you.
Thank you very much for this presentation. Unfortunately, we don't have more time. Please remember that all questions can be sent to our author by email. For my part, I would like to thank everyone for participating in this session and transfer the voice to the organizers. Thank you.
Thank you, Dr. Jury. I don't think there is anything up in the schedule for this session. I think Dr. Shabnam's talk was the last. So that almost concludes the conference. So I would like everyone to make their way to the plenary link so that we can have the closing remarks and conclude this conference. Thank you.
Thank you, everyone.